Hi, I'm Chris Bradshaw from Hexagon. In this video, we'll see how to use GT_strudl's GT menu module in order to create and perform finite element analysis. We'll start by creating simple construction lines and points in order to create the boundaries and then mesh automatically to generate the finite element analysis model, including the addition of internal boundaries for holes. Finally, we'll run the finite element analysis and review the results, including the graphical plot of the displaced shape or the bending stress contour plots. My colleague Ravi will take us through this.
Okay, so in this case, we're going to look at how to do finite element analysis advanced meshing using GT menu. So in this case, we're actually going to use the boundary lines that we have created and some points that we've created. These are not nodes and these are not members, but they are just construction lines and points. So let's see how to create construction lines. Okay, so if you go to create, and then there's a command called construction points. You can create points, you can create lines here by typing in the coordinates, or you can just transform existing node points to points. Okay, so here we'll go to circular 3-point option, and we'll just set the number of divisions to, let's say, 8. Okay, and then once we do that, all we need to do is just specify 3 points, and it'll actually create a curved surface for curved boundary for us. Okay, so we create those boundaries, and then we'll just create some internal boundaries, okay, which are actually represent holes of a plate. Okay, so we've created the 3 points on these holes. Okay, and these green lines basically now internally represent openings. Okay, so once we do that, we just have to do it for 3 more holes here. We can then go in and use a new tool to do the meshing for this plate. Okay, now what we're also going to do is also connect these holes with some boundary lines. What we really want to do is have some stiffener plates attached to this plate that I'm actually creating. I'm not going to be creating that stiffener plate here in this video, but I'm just going to create the boundary lines. Okay, so those boundary lines are basically lines connecting these circles that I've drawn, and let me show you how that looks like. Okay, so this is a first boundary line, and what I'll be able to do on that boundary line is control the mesh density along that line. So if I have to attach let's say a stiffener plate to this plate, I have an edge to connect to. Okay, so we're done with the hard part. We're done with drawing the boundary, external boundary, and the internal openings and the boundary lines. Now we'll go to this tool called Joint and Element Mesh tool. So we'll just go in and Elements and Joint using Mesh. Here we'll go in and define the thickness of the plate that we want to create. Let's just do 100 centimeters. Okay, so then we'll go in and choose the element that'll be used here to create that. It's going to be the SBMITC element, which is new inside GT_strudl, and then I'm just going to select the boundaries, okay, for this mesh to be created. Okay, so that's first we define the outer boundary of the plate. Now if you do not click on the X, it'll assume that you have not closed the area like I did here. So you really need to be careful here to select the X's. Okay, otherwise it won't do the meshing properly. So you just have to go in and select the X's here to define that as the outer mesh boundary. Okay, so once we've done that, it'll show you all the boundaries that form the outer boundary of this plate. Now here I'm going to go in and specify some parameters. Okay, we'll take care of that later. Then we're going to go in and add the internal boundaries. Okay, so we're going to select these circles like you see here, and you just right click on them, click on the axis, and then right click. If you make a mistake, you can go back into that dialog box and delete that boundary by selecting it. So here you see that it's automatically saying that the boundaries that I'm selecting are openings. It's smart enough to know that because it detects it as a closed a boundary, okay, within a closed boundary. So you can actually change that if you like. If you don't like it to be closed, if you like it to be closed, you can just say no, and it'll actually mesh the internal of that boundary also. Now I'm going to go and specify the attachment points, lines. Okay, so you can see now it tells me what is contained in each of those boundaries. Okay, what lines are contained in each of the boundaries. Okay, so now we go in and generate, and we see some there are bad elements that are being created. So I'm just going to undo that and change this to 0.25 and now generate the mesh. So we have some bad elements again. So I'm going to go back and change that to, let's say, 0.5. Click on generate mesh. So this worked. Okay, so now we don't have any bad elements created, so we can just say done. And now it's a complete finite element analysis model. So we can assign supports to this, like you see the rendered mode here. Going to go back to wireframe and just attach maybe 3 supports. Okay, let's just create 3 supports. We'll go in and assign a uniformly distributed load. Okay, we know the plate thickness, we know the material is steel, so it should be able to go in and calculate the self weight of that plate. And let me just run the analysis, and the analysis is almost done. Okay, now let's go in and review some of the results. Now this is the display shape, as you can see. Let's go and view finite element analysis results, and these are the bending stress contours.
Right, well, thank you, Ravi. Now, I hope you found that video useful, but remember, if you do have any further questions, please don't hesitate to reach out to us at Hexagon. Thank you for watching.